All right, this video is for AP Calculus, AB and BC, section 5.7. And if you have not watched the 5.6 video yet, I would say you definitely want to watch that before you watch the 5.7 video to make sure you've got the background that you need. In 5.6 we talked about differentiating inverse trig functions, and now we're going to talk about integrating certain expressions that lead back to those inverse trig functions. So I put a little note up here at the top that says these would be integrals that don't really fit patterns that we've seen up to this point. These are going to involve fractions. The key really is to recognize the pattern. So it's going to take a little bit of practice on our part to get to a place where we can recognize this. We'll talk a little bit about that here. And ultimately we want to realize that the integral is an inverse trig function, or it's going to lead to an inverse trig function, specifically inverse tangent or inverse sine. So if you take a look at what's below here, you can see I've got a couple of indefinite integrals set up, and really the hope is that we look at this and we look at this and we recognize it. We recognize it from back in 5.6. So that's why it's really important that we have that 5.6 stuff very familiar and solid before we try to tackle this. So the top integral here is basically the integral of the derivative of arcsine. And so this would end up being the arcsine of u over a and then plus c, because we're doing an indefinite integral. What's the bottom one? Well, the bottom one is similar. This one ends up being the arctangent of u over a. So this would be an important piece here for you to have recognized what we've done in the past and be able to apply to what we're doing right now. So we're going to just look at a series of examples here that involve these, and we'll be working a lot with the u's and the a's to hopefully make these make sense. Okay, so our first two examples are right here. Number one, integral of 1 over the square root of 4 minus x squared. So, as I've encouraged you guys in the past, whenever you see the integral of a fraction, I would encourage that your first thought be to ask yourself, is this of the form of natural log? Is it ln? And in order for it to be ln, you'd look at it and have to see the pattern that the derivative of the bottom is the top. And here when you try to consider that, it is definitely not true that square root really changes things, messes things up, so it is definitely not natural log. So then the next thing to consider is it arcsine or maybe arctangent? And you look at it, and based on the familiarity you have from the past, you're going to look at this and see, the square root, the fact that it's 4 minus x squared, and hopefully you're going to recognize that it is arcsine, the form for arcsine that we see right here. And so I'm going to proceed from that perspective. So it is going to take some familiarity, some practice for you to recognize these, but that's the key. All right, so in order for this to work, I really got to figure out what my u prime, and my a would have to be for this to work, and see if it really fits the form. So looking at this, my u comes from this term down here, the x squared. And so if this is going to work, my u has to be x. And if that's going to be my u, then my u prime would be a 1. And then my a comes from this number here, if you remember that form from before. And so since that's a squared, then this would have to be a 2. Whoops. Let's try that again. This would be a 2. Let me remind you of that basic form, that the derivative of arcsine, what that really is. It's been a little while since you watched that 5.6 video. This could be confusing. So the derivative of arcsine is equal to this. It's u prime over the square root of a squared minus u squared. So I'm hoping you can look at that and see why we have the same kind of format, how this matches our integrand. Okay, so I'm looking back at that integrand, and I need to have my u prime in the top, and I do. My u prime is 1, and I've got a 1 in the top. So I would say this is perfectly set up for arcsine. So based on all that, understanding what we've got here, I'm going to write the answer. Arcsine of my u, which is x, over my a, which is 2, and then plus c. That would be my final answer right there. Okay, take a look at number 2. Just like with number 1, we do have the integral of a fraction, and I'm going to encourage you to always consider natural log first. So let's consider natural log. In order for the natural log pattern to work, the derivative of the bottom has to be the top. You can see again here that this is not going to work because the derivative of the bottom is 18x. The top is 23, and we're off by a factor of 18/23, but we're also off by a factor of x, and the x is the big deal. So this is definitely not natural log. The next thing I'd ask you to consider is it arcsine or is it arctangent? And if you're familiar with arcsine, you know that arcsine needs to have a square root in the denominator, and this one doesn't. So it's not arcsine, but it could be arctan because arctan does not need that radical in the denominator. So let's set up our u's and our a's. If this is going to work out, let's remember that the derivative, let me write this down here. Let's remember that the derivative of arctangent of u over a is equal to u prime a over a squared plus u squared. So we want our integrand to fit that if it's going to be arctan. So my u would have to be coming from here. And so if that is 9x squared, and I know that that's supposed to be u squared, I would say that my u is going to have to be 3x. That means my u prime will be 3, and my a, well gosh, there's a 23 up there. Maybe what we ought to do is rewrite this as 23 integral of 1 over 4 plus 9x squared. I think that's going to be the better way, just bringing that constant factor of 23 out. Well, so then a really just comes from this 4 down here. Of course, that's a squared. Hope you're seeing that down there. And so then, of course, 2 squared is 4, so my a is 2. So with all that set up, I think what I can do then is write this. This is equal then to 23. I want my top to be u prime a, and I can see from over here that u prime a is going to be 6, and it's only a 1, so I'm going to put a 6 right there, but I'm going to have to balance that out by putting a 6 under the 23. And then I've got my 4 plus 9x squared, so this now perfectly fits the rule for arctan. So my final answer is going to be 23/6 times arctangent of u over a, so that would be 3x over 2, and then we've got to have a little plus c in there. That would be my final answer. All right, and then 2 more examples here. Number 3, integral of x over x to the 4th plus 25. So again, just as a matter of practice, if you see the integral of a fraction, I'd encourage you to first ask yourself, is it natural log? So in order for it to be natural log, the derivative of the bottom has to be the top. Well, the derivative of the bottom would be 4x cubed. The top is just an x. We're off by, by a factor of 4x squared. It's not going to be ln. It doesn't work out. Then I'd ask you to consider arcsine or arctangent. And again, with arcsine, you need to have that, u prime over square root of a squared minus u squared. You can see that there's no radical down there to match that radical. It's plus instead of minus. So it's not going to be arcsine, but maybe it's arctan. Arctangent, of course, the derivative of arctangent is u prime a over a squared plus u squared. This kind of looks like that. So if we're going to make this fit that form, let's identify our u and our a. So u would have to come from this, and that seems to match up with x to the 4th. So I'm going to say that my u has to be x squared. That means my u prime is going to be 2x, and then my a is going to have to come from that 25, so my a is going to be 5. So then look at what I've got. I need my numerator needs to be u prime a, and it's only an x, and since it needs to be u prime a, it needs to be 10x, right? 5 times 2x. So I'm going to write this now as integral of 10x over x to the fourth plus 25. Of course, I can't get away with that. I can't just multiply the top of the fraction by 10 unless I also multiply the outside by 1/10. Now it perfectly fits arctan, so it's going to be 1/10 arctangent of my u over a, so x squared over 5, and then plus c. All right, our final example is number 4. Again, as always, I encourage you to stop the video, pause the video, and try these on your own, and then check to see how you did later. Okay, so number 4. I always encourage, consider when you're doing the integral of a fraction, consider ln first. Hopefully you can see pretty quickly that ln's not going to work because of that square root. So the derivative of the bottom is definitely not the top. So then the next two things to consider would be arcsine and arctangent. So this does have that radical, as I mentioned earlier, and it is minus. And so really, if you think back on what we know, I think arcsine is the much better fit based on that denominator. So that's what I'm going to go with. So if you recall, the derivative of arcsine is u prime over the square root of a squared minus u squared. So I'm going to try to make this fit that form with my u's and my a's. Let's see if we can do it. So my u would have to match up with u squared, and that looks like it's going to have to match up with 16t squared. So if u squared is 16t squared, I'd say that u would have to be 4t. Therefore, u prime would have to be 4, and my a comes from a squared, of course, which seems to match up with that 9. So then I'd say my a would be 3, since 3 squared is 9. Like we did before, I'm looking at that numerator of a 5, and I feel like we probably ought to bring that out. So that's what I'm going to do first. I'm going to make it 5 integral of 1 over square root of 9 minus 16t squared. So I know my top needs to be u prime, and I know that u prime is 4. Obviously I can see that it's a 1. To make it a 4, I multiply by 4, and then of course divide by 4 on the outside. So now I've got the perfect arcsine pattern, so it's going to be 5/4 arcsine of my u, which was 4t, over my a, which was 3, then plus c. I'll zoom back out here a little bit so you can kind of see the whole thing, but that would be my final answer right there. Hope this video has helped. Look forward to seeing you in class, help you with any questions that you might have.